Hello and welcome to this section of the MATLAB tutor. Here in this section we're going to continue multiplying matrices, but we're going to teach you how to do it element by element. And you should remember this from back when we talked about vectors. We talked about multiplying vectors element by element. Now this is not really a math operation that's defined in terms of textbook math, in the matrix algebra class. You're not going to learn how to multiply matrices element by element. It's not something that's typically defined, but it can come in handy when you're dealing with large data sets. All right, so what we're going to do is define a matrix, and I'm going to call it cupcakes, and I'll explain why in just a minute. But let's say what we have here is a 0 space 2 3 3 4 semicolon 1 1 1 2 2 or something like this. All right, and then let's do another row 4 3 2 3 2, something like this. So here's a matrix. We have 3 rows and 1 2 3 4 5 columns, and you can see I've separated everything here. We hit enter. This is cupcakes. Now what do I mean by this? Why would you want to do this? Let's say that this represents a classroom. Let's say you're a teacher. So if you're looking down on top of your students, so these are the desks in the classroom. The chalkboard's up here at the front. So here you have little Johnny here, and Mary, and Sally, and Jenny, and all these students, right? So this is the front row, this is the middle row, and this is the back row of the classroom. And I don't know why, you ask them to bring some cupcakes, right? So this person brings 0 cupcakes, this person brings 2 cupcakes, this person brings 3 cupcakes, and so on, like this. Now let's define another matrix called days, okay? And we'll do, one, let me go ahead and put it into a matrix, and we're going to make it the same size. So 1 1 1 2 1 colon or semicolon 2 2 2 3 2, and then the last one 0 0 0 1 2. Something like this. So it's the same size, it's just different numbers here. Now here's the second matrix. So I have cupcakes and I have days. So the first one represents physically the classroom layout and how many cupcakes each student brought to class. And the second one is how many days they brought those cupcakes, right? So, some kids, like this one here, only brought cupcakes one day during the week. Like maybe his mom didn't have as much money, they were able to bring cupcakes and so on. This kid brought cupcakes only one day. Now notice that on that day that he brought the cupcakes, he brought 2 cupcakes, but he only did it one day of the week. Now this kid over here, he brought cupcakes 3 days of the week, and each of those 3 days, if you look at the other matrix, he brought cupcakes 2 days. So it's pretty clear that for this kid, if he brought 2 cupcakes to class on each day that he brought cupcakes, and he also brought cupcakes 3 days a week, then 2 times 3 is 6. So for the week, he brought 6 cupcakes, or she brought 6 cupcakes. And we get that because we're multiplying element by element like this. So this kid here brought 4 cupcakes, but only did it one day of the week, so they brought 4 total cupcakes to class during the week, right? So the way we're doing that to get these answers is we're multiplying element by element. The number of cupcakes the kid brought and the number of days that they brought them should give you the total number of cupcakes. All right, so if you try to multiply these things together, cupcakes times days, then you're going to get an error. And you shouldn't be surprised by that, because when you try to multiply matrices in MATLAB, it's going to always try to do it in the proper mathematical way. It's going to make sure that the number of columns that you have in the first matrix is equal to the number of rows that you have in the second one. In this case, you only have 3 rows here, and you have 4 columns, so there's no way to mathematically multiply them. And even if you could multiply them, like if I added some more rows or something crazy like that, then it's going to multiply them in the mathematical way. It's going to multiply each element across and then down, and it's going to sum them together across, down, across, down, across, down. It's going to sum everything together and give you the elements of your new matrix. But you can see from our actual problem that we don't really want to multiply this in the real mathematical way of across, down, because it's not physically tied to what we want. We have a kid bringing 2 cupcakes to class one day a week. We want to multiply element by element, and get a new matrix that represents the total number of cupcakes. So let me bring up that last calculation, and we did this before with vectors. We put a dot, which is a period. We put it right in front of our operator. In this case, the operator is multiplication. When you put a dot, like a period, in front of multiplication or in front of any operator in MATLAB, then it's going to tell MATLAB to do the operation element by element. It's going to tell MATLAB, don't try to do this in the real mathematical way that we learn how to multiply matrices. Do it element by element. So let's hit enter. We get a matrix back. This matrix is going to, I can do total cupcakes equals cupcakes dot times days. Okay, so now I have the total number of cupcakes each person brought. So you can see the first person here brought 0 cupcakes one day of week, right? That's kind of a silly definition, but that's what happened. So they brought 0 total cupcakes. This person over here brought 4 cupcakes because they had this times this. 3 times 2 up here gives us 6, and we got a lot of zeros down here, but that's because these people brought cupcakes on 0 days of the week. You can see that here, 0 days of the week. And of course we have some data here in the matrix, but they actually didn't bring cupcakes each day. And another way you could look at this is the teacher assigned each of these students to bring a certain number of cupcakes, and they chose to bring them to school a certain number of days. And so this is the total number of cupcakes that we actually have. And it's worth saying here, I tried to come up with a hokey example just to kind of show you why you might want to multiply element by element. It's a little bit silly, but there's a chance that you might pull in some data from a outside source, like a survey or some experiment or something. You have a matrix here, and you have another matrix of data, and they're related, much the same way we've set this example up, and you need to multiply them or divide them or something. But you're not going to do that in the traditional matrix sense. You need to put that dot in front of your operator. You can go ahead and clear the screen here, and as we've tried to come up with this example, I've showed you how to multiply these matrices together and how that might be useful and do it element by element. We can actually take cupcakes. Let's go ahead and put cupcakes there. Let's put days back on the screen. We can also divide these guys by putting a dot and then a divide like this. So what this is going to tell MATLAB is go ahead and divide these matrices by one another and do it element by element. That's what the dot is saying. So you hit enter, and then what you get is this matrix here. So 0 divided by 1 should give you 0. 2 divided by 1 should give you 2. And so all the division is occurring element by element. You get 4 divided by 0 here, and so you get infinity for a couple of terms because anything divided by 0 is basically going to give you infinity. So MATLAB's reporting that to you here. So the bottom line is when you multiply or you divide matrices and you want to do it element by element, you have to explicitly tell MATLAB to do it with the dot right in front of your operator. And this is exactly what we did for vectors. I gave you a similar example for vectors and told you if you want to multiply or divide them element by element that you had to do the same thing. All right, now one final thing I want to show you here while I have your attention with a kind of a practical example. Let's go ahead and put the matrix total cupcakes on the screen. This is what we got when we multiplied cupcakes times days, right? These were basically, this represents how many cupcakes each student actually brought during that week when you multiply them together, right? Now, what if I wanted to find out how many cupcakes total were actually brought total? If I wanted to add them up, now obviously it would be 2 plus 3 plus 6 plus 4 plus 2 plus 2 and so on, adding everything together. I can do it by hand, but what if this matrix were, 1,000 by 1,000? That would be kind of cumbersome. So you want to add them. You want to figure out how to use MATLAB's power to do that. So if you remember back from vectors, there was a function called sum. So if we actually pass a vector, which is just a single row matrix to this guy, it just adds everything up in that row. Now this is not a vector, this is a matrix. So if we take the sum, what we're going to get back is not exactly what you would expect. You really think it would add everything, but what you get really is a sum of each of the columns. Okay, so what you get here is you're adding these 3 things together, you're getting 2, you're adding these together, you're getting 4, you're adding these together, and so on. But still not exactly what I want. I want to know how many cupcakes did everybody bring together. So what I really want to do is I want to add all of these numbers together. So I'm trying to illustrate to you that when you apply the function sum to a matrix, you're going to get a vector back, which is going to be the sum of each of the columns. But if you do it again, if you do sum of the sum of total cupcakes, it's a great example of how you can nest functions within one another to pull that off. So this guy is going to be evaluated first inside the parentheses, and what you're going to get back is this listing of numbers here, and then which is a vector. And then when you apply the sum again to this vector, it's going to add them all up. We've done that before when we studied the vectors in the last few sections. So when you apply the sum to a vector, you add up all of these elements. So effectively, this outside sum is going to add up all of these numbers. And so what you get is 38 when you actually evaluate it, 38 cupcakes, right? So when you do it like this. A more clear way to figure that out, if you do, let's do column sum is equal to the sum of total cupcakes, right? I can create another variable, which is a sum of the columns of each of these people, right, like this, and I'm going to make it equal to the sum of the matrix total cupcakes. It's going to give me a vector back. It's going to be the sum of each of the columns of the people in class, and then I can apply the sum function to this guy, which we have learned how to do before, and you get 38. It's exactly the same thing as saying sum of total cupcakes. It's going to give you the exact same answer either way. Two ways of doing the same thing. I'm trying to show you different ways of doing things in MATLAB so that you understand how it's fundamentally working and you can get good at it. So make sure you understand how to multiply element by element, how to divide element by element, and sometimes you might need to use the sum operator, and just make sure you understand how MATLAB functions so you're not surprised when you get something like this back. That is exactly the way it's supposed to operate.